All Things Ansys, a podcast from the technical support staff at PADT. Episode 62, we talk about using Ansys Granta for exploring material options available in additive manufacturing, as well as news and events from around the Ansys world. Welcome to another episode of our podcast. I'm Eric Miller, one of the owners of PADT and your host for this podcast. Lots going on in the outside world, as we are all very aware of, as we work our way through this COVID-19 pandemic. And we'll talk about, actually in the next episode, we're going to talk about how people are using Ansys to respond to the disease. But this week, I thought we'd just talk about other stuff. I think we could all need the break. We could all use the break. This is episode number 62, and we're inching up to almost 20,000 downloads at 19,334, with 61 episodes before this one. That's moving up a little bit to 317 per. Please do spread the word and let people know about the podcast. If you enjoy it, they might too. Things at PADT have adjusted well, and we're working hard. Really no big change in the things we do, just where we do them and or how we do them. If the folks working in manufacturing in the office with the physical spreading and time spreading as well. Each of our we're hoping that each of our simulation engineers gets noticed in their neighborhoods as the person who's doing the most non-video bits across their neighborhood internet. Everybody else is streaming. We're downloading CFD files. It's a strain on said network. Today. The suspension of face-to-face meetings has led us to a lot of PADT hosting a lot more online content for additive manufacturing, which we usually call or commonly call 3D printing. As part of that, we want to cover how the Ansys Granta product plays with additive manufacturing and make sure people are aware of the large spectrum of properties available in this niche area. So I'm not going to say more. I'm going to let Rob and Pam, who are joining us for the discussion, share what they know about using Ansys Granta to understand material properties used in materials used in additive manufacturing. So I want to welcome everybody to another interview or discussion, actually, on the All Things Ansys podcast. Today, we're talking a little bit more about Ansys Granta. And I've got with me Robert from our Texas office and Pam, who is usually from our Phoenix, Tempe office, and all of which are working from home right now. So welcome, guys. Hello.
Hey, good to be here.
Why don't you, Robert, start, introduce yourself, what you do at PADT and what how you got into simulation. We always like to hear about that.
All right. So I've been working at PADT for almost 2 years. I'm an application engineer. Prior to that, I started using Ansys in school, and then throughout, I had a career a little over a decade long in the maritime and offshore oil and gas industries, focusing mainly on ship structural design. So I was using a lot of beam and shell stuff, big shell models.
Cool. Very cool. Large structures. Yeah. Mm-hmm. And that's not an industry we really want to talk about right now, but
negative oil, not so much. Yeah.
Negative oil. Who would have thought?
Yeah.
And Pam, I know you've been on the podcast before, but just in case we have new listeners, why don't you introduce yourself and what you do at PADT?
Okay, thanks, Eric. I'm the 3D printing application engineer, so I get to talk to users in all sorts of industries to share information about how they currently or potentially could use additive manufacturing equipment to solve all sorts of problems, from doing prototypes to creating tooling to end parts. And I've been in the additive field about 20 years, so it's been really interesting to see the evolution of both the systems and the materials. Mm-hmm.
Yeah, it has come a long way, hasn't it? Wow. Well, today we're speaking of materials. That's what we're going to talk about today. Granta was not. I guess we can't. Can we say recent? I guess it's still a recent acquisition.
Yeah, it's fairly recent.
Fairly recent by Ansys, of a bunch of smart people and a lot of data and a really cool piece of software. And Robert, why don't we start with just kind of an overview of what is Granta? What are the different products within the Granta family, and then we'll come back with some more questions.
All right. So Granta was originally started in I think is part of a kind of research thing with the University of Cambridge. There's one professor there who pioneered it, and he was originally setting it as an academic material database. So if you were doing, a engineering project as a student or as a researcher and you need to know about materials, Granta would have that there. It was then rather quickly moved into the commercial side throughout the early 2000s. And from there, it expanded into other programs, specifically more like drafting, et cetera, focusing on Granta just to specify materials. And Ansys acquired it really because Granta has a very large library, thousands and thousands of materials to choose from and select from a wide variety of materials. So you can look at things from, I want to look at steel, or I want to look at a polymer, or, I want to look at a textile, or I want to look at some properties of, some clay. It's all in there, and it's engineering and usage focused. So the data, it's a huge database. So you can't, the power is in that within the material listings within this database, some of it is directly from manufacturers in terms of cut sheets, data sheets, and even some testing, like JOM curves, stuff like that. And otherwise, it'll be based on a statistical average or some other statistical data brought on by some sampling done by Granta themselves from amongst industry-wide sort of things. So if you take an average value for a yield strength, or even a cost, or this and that, that's taken from multiple manufacturers. Or if it's in terms of empirical data or mechanical properties, that's from multiple manufacturers, multiple tests. So it's widely representative of what's available in the market, and it's updated.
Even more important, right? We're still using 10-year-old mill handbook data in a lot of cases if we don't have Granta. And there's multiple products, right? So there's one that's built into mechanical, right? And then you kind of work your way up from there.
Right. So you have the materials data for simulation, and that is within mechanical. So within mechanical enterprise, there's a demo of the product, and it's some odd many hundreds of selections within the Granta library. And then if you get the full one, it moves up to I think a couple thousand. So that's looking at linear elastic models and just basic properties already set out for you. Then the next level up is CES. Well, it's now Granta Selector. Yeah, last year it was CES Selector. Now it's Ansys Granta Selector, and that is the regular database. That is a single end user needs a license. I can have that at the computer. And you can select from the database. You can import your own data into the database as well. And much as I said earlier, it's really for rapid material selection and comparing what you have on hand versus what you could use. Then the next step up is Granta MI, which is the flagship, which is kind of more appealing to, throughout an organization in terms of usage, and not just basically engineering and procurement, but this is, how it's fielded throughout. And that is more of I'm fairly certain it's functions on a network. So you just kind of pull it up on a website and open your browser, and there you go.
Cool. Yeah, a lot of different capabilities, and we've been really fell in love with it, I think, pretty quick, mainly because most simulation people, we've been struggling to get accurate or just get any material data, let alone accurate material data, and having the actual data to back up where the data comes from, the information to back up where the data comes from is really very, very cool. one of the things we wanted to focus on today, and the reason why Pam is here, is what a lot of people don't realize is that Granta has 3D printing or additive manufacturing material data in the database, and it's fairly comprehensive, correct?
Yes, yes. Right now, I believe they have 850 materials that are relevant to additive.
So if you're doing a simulation and you want to know, if I switch to an additive material, what kind of properties can I get from it? That's something you can now do with the tool, which is pretty handy. I think that's one of the things that keeps people sometimes from looking at additive materials is not knowing what the properties are. So that's huge. Mm-hmm. Where did it come from? So there's a little bit of history behind the database. So we wanted to kind of cover that. Where it came from someplace else, right?
So the Senvol Database has been around about 6-7 years. It's from a company that was started by two people in New York City and is still there. They were colleagues from grad school, as I recall.
Gotcha.
They decided that was a niche that was missing, as you say, to have one place to start looking. A couple of things I like is it's free in, when it's embedded in this, you don't have to pay anything extra. Mm-hmm. And it has a way to search by machine, if that's something that is relevant to you. So for example, if you wanted to find every metal powder bed printer worldwide that has a build volume of 1 cubic meter, you could do that. You could even drill down and say, okay, it has to have an X dimension of at least 36 inches, something like that. You can search by how many printers can run a certain alloy of titanium. But what also makes me interested, and that's very relevant to the Ansys work, is that besides the machine database is the material database. Mm-hmm. And they've set it up really easy to use. Again, you can put in minimal parameters. If you know a particular material type, you can just search and it gives you properties. Or if you want to put in a process, say, I only want filament FDM, or right. I only want some kind of polyjet, or if I want DMLS. Beyond that, you can put in by mechanical properties. So you can say, I need something that has a minimum tensile modulus of such and such and a maximum, or a minimum ultimate tensile strength. You can put in hardness scale. You can search by heat deflection temperature. It's really amazingly comprehensive.
So, and very powerful, right? So you're picking a material. Instead of finding a material and then seeing if it fits, you can say, this is what I want it to fit within. Now give you materials that fit within those boundaries, which is really nice. Yeah. I forget which Granta tool it is to correct me. Selector, right? You can actually do comparison studies and kind of Venn diagram type looks at these different properties between the different materials, correct?
Yes, you can. So you can have multiple levels of filters based on whether you're looking at like a tree within a library. So if you're looking at, I want to look at such and such family of polymers or whatever, you can scope it to that, or you can scope it based on properties, etc. And you can just keep on adding until you get down to having like one or two materials, or you can have this broad selection and then make a chart of it, and it'll show your selection compared to the rest of the available materials or the rest of the Granta library, and show it where it fits. And you can do it based on an absolute scale or a relative scale. So if you're looking at, like, say, mechanical properties versus price of material, you can have one axis be, your mechanical property, and the next one be your price, and then set it to be relative. So your selection, you set a reference value, a reference material, and then that becomes your one, your unity. And then anything, left of it is, if the price is on bottom, then anything left of it's cheaper than it, and anything to the right of it is more expensive. And it's a very easy way of seeing what's going on. And then again, with these charts, you can apply your levels of your filters that you've been applying and turn them on. Or you can also do, like you said, your Venn diagram of, there's these different families, how does this fit? And it'll outline in those selections where that family of materials is. And it can also put out, reports, and you can do large comparison tables, and then say, within so what many percent, like, say, show me, highlight everything that's with 10% different than the original. And move from there. And one of the big use cases I heard earlier was, due to, I think it was even the beginning of the end of last year, when a lot of factories were closing down in China
shut down.
due to coronavirus. People were looking at, hey, where can I get this stuff? So you would look at the material you had, and then you could find out, kind of where in the world it's being made from different manufacturers to find alternatives.
Good point. We never really planned for scarcity on our material supply chain, and now it's a reality. So true with additive. So far, we've been okay on the supply chain for additive. I don't think we've seen, at least with the industrial machines, too much of a shortage. I think getting people to work safely in the distribution center was the only hiccup we had, at least on the Stratasys side of things. So if I wanted to have access to the additive material database, does that come with the product, or is that an add-on, or which module do I need?
Right. So you would need the Plastics Plus section for the Senvol database.
Okay.
So for the full additive. Otherwise, there are some additive materials that are included in the default, but otherwise it will not list like regular machines and what you can tie onto it. You do need a separate one for it. But once you have it, it's on. You can use it from whatever library setting you have, provided the materials you have are within that library.
The library.
Yeah.
Very cool. And I think it's always worth noting when we talk about Granta, you can add your own materials to the database, correct?
Yes, you can. Good. And there's I think there's more options within Granta MI in terms of all information you could toss in, but there's some rather basic options just from the get-go of just tossing the material, but you can have some expanded ones within Selector as well.
Cool. Well, that's important because sometimes you got some material that's not out there, but just the fact that everything's available is really, really powerful. It seems pretty straightforward. If people are interested in learning more about Granta, what's the best place for them to go to get more information?
So there's the Granta website. That has a whole lot of information about the various Granta products and databases. Or you can ask us if you want to as well.
Yeah, I was gonna say, reach out and we'll get you a temp key. I think that's what I would recommend, and just see how it works. It's pretty. We haven't had a lot of customers look at it and say, "Yeah, it's not worth it." They seem to really like it. It pays for itself pretty quick, I think. Yeah, cool.
Yeah, I'd say especially the materials data library. As being and doing a lot of FEA as well. It's one of those things where I'd have some material that wasn't assigned default within the Ansys material library, because Ansys material library is really looking at it from a material model standpoint and not just a basic material standpoint. So having that just set up all the linear elastic properties would have been a nice thing to have years ago. So now it's here.
Yeah, very cool. Anything else you guys want to add before we wrap it up that people should know?
I think I just wanted to throw in on the Senvol. I'm just skimming it. They even have an option if you need to find material that has been certified, tested for something like flammability. It drills down to that level of detail.
Very useful. Yeah, very, very useful. Wow, it's a whole new world.
Yeah.
It's been a while since I've hunted material properties, so I actually remember taking pictures or scanning books and converting those into graphs on the computer. So it's been a while. So we've come a long way. We've come a very, very long way. Well, I want to thank you guys for taking a little bit of time out of your Friday. I hope you both have something fun planned for the weekend, and get out of the house or at least move to the backyard. And,
yeah.
I appreciate your time, and we'll hopefully talk soon about some more about Granta and additive manufacturing.
Great. Thank you.
All right.
Thanks, guys.
Hey, thanks.
Okay. That's very good. Thanks. It's not a really in-depth topic, so we don't need to go too long on it. Yeah, it's pretty straightforward. I love it though. Wow, what a huge time and cost savings. Just amazing. So glad they bought that one, those guys. All right. Well, this will actually go out Monday, I think. So
Okay.
I'm going to record the front and the back of it and put it all together and send it out. So now I'm going to go off and read Ansys News.
All right. Thanks, Eric.
Yeah. So Pam, did you see the planes at all?
Yeah. Oh, I sent you the video.
Yeah,
clip.
you sent me the
Did
video.
you?
Okay. Yeah.
Yeah.
No, sorry, you did. A bunch of people didn't. I guess they were early.
They were a little early. Yeah. They were like by 12 minutes, which is everything.
Yeah, and they didn't follow the route. So I guess Rob barely saw them. He drove over to PADT because it looked really good, and they were really low, I guess. But they went right over Karen's house. So she said it was really cool. Yeah. But pretty neat. So what we're talking about, Rob, is we had the local Air Force Base and Air National Guard had 7 F-16s, 7 F-35s, and a KC-135, I think.
Yeah, it was something big.
Yeah, it was a tanker of some kind. I forget what the new tanker is. It's not a 135. They did an orbit of Phoenix, not as prescribed. So back in the day, that was my dad's job. He was chief of operations at Luke.
Wow.
After he was a squadron commander there, and then he did that for a while. And he would do these public display things back then. And all I could think of was, if he was in charge, they wouldn't have been off time.
Oh,
I'm thinking that the Air Force is slacking a little bit. That would have never happened. I mean, oh my gosh, I can't believe it. They must have been waved off of their route for some reason because of something. But yeah, there were no planes. I noticed there was no other planes in the sky when they were doing it. But in Ahwatukee, we could hear them. We could hear the rumble, but we couldn't see them. Cool planes. Were the F-35s pretty cool? Can you tell they were different?
it was hard. They were distant from me. I was expecting them to be closer where I am. As you say, I think they went a lot further south of Tempe instead of swinging east.
Yeah. Yeah, it seems like they changed their route. Well, cool. I'm glad there was a chance to see a little bit of it, though.
Yeah. Okay, well, thanks, and have a good weekend yourself, and good to chat with you, Rob.
You guys enjoy.
Right.
Bye.
Okay.
All right.
Bye.
Y'all have a good one.
Thanks, Rob.
Thanks.
You're welcome.
Bye. So there you have it. Kind of every engineer's dream built into to Ansys now, for more than just basic material data. It's a lot more. It's a real tool whose use goes beyond simulation, and hopefully those of you in other areas will find the value in it, as we have found as Ansys users. We do have a webinar coming up for additive manufacturing users, but it is also applicable to Ansys users. It's called Optimizing Material Selection for Additive Manufacturing with Ansys Granta. That's on the 5th of May at 11 o'clock Pacific and Arizona time. You can always go to brighttalk.com and search for PADT to find all of our webinars, including this one. Searching for Granta will probably turn up this specific one, or the easiest way to get there is to go to www.padtinc.com/events and find whatever you're looking for there that we're talking about. So commercial time, please do consider PADT as your Ansys supplier. If you're in the southwestern U.S. and for simulation consulting and customization everywhere. We are also just as good at additive manufacturing and product development, so give us a try. We love what we do, and our customers tell us we are good at it. These times are difficult, and you may be facing some challenges you never expected. PADT is here to help. Just reach out and let us figure it out. We have moved most people home, but we still offer all the same products and services, including 3D printing. So news-wise, let's talk about the Ansys stock. What a difference a week makes, or a couple weeks make. Ansys stock is back up to 255.65 as of today, May 1st, which is when I'm recording this. It went as high as 266 this week, I think on Wednesday, then went down a bit today. As a reminder, it peaked at 299, so that's only a 14% drop from the peak, and we're about where we started last at the beginning of the year. In fact, it's only a 0.52% drop from where Ansys stock started in January 1st, whereas the S&P 500 is down 12.5%. So that's good news for the company of Ansys, their employees, and as well as for all of us who are users. Ansys news-wise, there's not a lot. There was a press release they put out about a story about how Ansys and a company called Software Motor Company are developing an ultra-efficient switched reluctance motor. If you want to know what that is, go read the press release at Ansys. Just Google Ansys News. It'll be in there. It's pretty interesting, the use of simulation to really get a super efficient, or as I say, ultra-efficient motor out of it. So the sort of thing we're looking to do is save energy and money by having more efficient motors. We've got no news on the PADT front, so nothing to report there. Ansys blog-wise, there's a couple of very interesting articles, as usual, actually 3 that I picked. The one that I found the most interesting was How Do Adhesives Work? So it's a look at the science of stickiness. We're seeing more and more people use Ansys to model adhesives, and adhesives basically coming apart or failing. And this is kind of an interesting look at the science behind all of that. The next one that I liked was simulating military electronics from microchip to mission. It's all the different ways you can simulate in this very, very demanding environment. We do quite a bit of work in that area, and we know that the specifications are severe, and it's great that you can model all these different aspects of electronics within various military applications. And then anybody with any kind of an educational interest, whether for yourself or your kids or if you're at a university, it's how to encourage multidisciplinary design with examples in the classroom. It's a real practical look at how you can use real-world examples to teach people this idea of multidisciplinary design, that they can jump across different disciplines. We added something to our blog. Pam, who was just in our discussion, wrote a great article about the new 3MF file format, and that's replacing STL for 3D printing. Finally, STL was one of those temporary files that should have gone away a long time ago and is still around. It's still a faceted representation. You're still covering your surface with triangles, but what's different is it's extendable, and she'll go into more detail about that. But the most important part is you can assign colors and materials to volume. So colors to surfaces, texture to surfaces, as well as materials to volumes. So it's very useful for 3D printing in color, and that's why we're excited about it. And the reason why we're talking about it is that the Stratasys software tool GrabCAD now supports that format. Most CAD packages have been adding it over the last year or so, and now we can support it with 3D printing. So as soon as Ansys outputs in that format, I can guarantee you that we will be talking about it right here on the All Things Ansys podcast. Upcoming events, we have a webinar coming up, which we already talked about, the Optimizing Material Selection for Additive Manufacturing with Ansys Granta on the 6th at 11 o'clock. And then our next one of interest to anybody and everybody is about fighting COVID-19 with 3D printing. So we've taken a group of our additive manufacturing customers and asked them to come on and be on a panel that I'll be moderating. We'll be talking about all the different things people are doing. As an aside, many of you are doing things with Ansys to fight COVID-19. And like I said, in 2 weeks, we will have an interview with 2 wonderful people at Ansys who are involved in promoting the use of Ansys in the healthcare industry. And of course, they're very aware of all the not all, but a lot of the applications in the COVID space. So do tune in for the next episode to learn more about that. The big event in the Ansys world coming up is that Simulation World is less than 30 days away. So if you haven't registered, do register now. If you want to know more about it, go to simulation-world.com and take a look at all the speakers. It's a really impressive group of industry speakers as well as Ansys people. And then users will be talking as well. Those are the speakers, but users will be presenting their work. It's pretty cool. Really excited about it. Again, that's 30 days away. It's in the beginning of June. Do check it out. That's our podcast. A little short this time, which is good. I think we all need a little bit of a break. I want to thank you all for attending. Don't forget to subscribe to www.padtinc.com/opt-in. Go ahead and spread the word about our podcast. And as always, do not hesitate to reach out. So as we like to say nowadays at PADT, stay safe and healthy, and then productive. Thanks. Thank you for joining us for the All Things Ansys podcast, episode number 62. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.